Thanks for joining. Today we are going to talk about small language models. This is the third session in this series. Previously we have covered RAG, the baseline RAG and the graph RAG. And today we'll focus on small language models, which are really powerful and you can actually run them locally, and that I will demonstrate. The approach is very similar. We'll discuss concepts backed with technologies and example, and these sessions are meant for anybody who's interested in GenAI. I'm purposely keeping these sessions at a conceptual level so that anybody who's joining this session can benefit. And I back all my talk points with demos just to make sure that the knowledge is grounded with some practical experimentation and implementations. And if any of you who's interested in doing more detailed deep dive, I'm happy to do that in some other sessions. I use Azure platform essentially to run some GenAI models, but whatever I'm discussing is agnostic to model providers as well as to the platform providers like Azure or AWS. And I use open source frameworks, languages, and tools. The idea is whatever you gain out of these sessions, you can apply it anywhere using open source technologies. Please join my LinkedIn group for industry news and details about things happening in the GenAI world. If you have not joined already, I also conducted similar sessions on Copilots, LangChain, AutoGen, and if you're really starting now, you can also go through them to learn more. Let's start the session today, and I'm taking an analogy from car industry. So if a GenAI app is like an automobile or a car, then a language model is the engine, and both are complementary, which means we require a car with engine and other components like electrical system, chassis, tires to make that function complete. And similarly, when we are talking about GenAI application, you essentially have a core component in the form of a language model, but you also need some overarching components like orchestration, automation to really fulfill the requirement of a GenAI use case. Let's understand what kind of infrastructure is required to run GenAI models. You already know about CPUs, Central Processing Unit, which is there for long, essentially in every computer that we use. And they are very general purpose in nature. They can perform a very diversified task. Over a period of time, computers have been used for entertainment purposes like gaming, which requires better graphics management, and that's where GPUs came into being, and they started providing much faster computation in terms of video rendering, which is required for gaming use cases, and perform mathematical calculation. They do a lot of things parallelly, and they have higher memory bandwidth so that it can actually process and ingest a large stream of data. Graphical processing units were also used because of the similar nature that you have to run inferencing and the training of AI models. And over a period of time, it was realized that for AI workloads, you require a specialized hardware, and that gave birth to neural processing units. and probably going forward in different uh, configuration, you'll have neural processing units embedded as part of your computer hardware. Before we start talking about small language model, let's understand what is a large language model. LLMs are basically called foundation models. They are based on machine learning and they use deep learning specifically and trained on a vast data source from public internet sites like Wikipedia, Archive, and other sources. And they are basically designed to perform a very general purpose task based on the inputs. For example, large language model or language models can perform um, code generation, text summarization, generation, and, and other things. The key characteristics of these models, they are trained on broad data, are flexible, can be used or reused for different applications, but they are highly resource intensive. They require a lot of compute power in order to run both training and inferencing workloads. But they can be adapted very cost effectively to perform a specified task based on fine tuning, which gives a head start for anybody who's trying to uh, train a model in a domain specific way, and that can really cater to a particular domain which has a specific uh, requirement functionally. Some of the popular LLMs are GPTs from OpenAI. OpenAI has been kind of a front runner in the AI space, specifically in Gen AI. But there are other products which are equally good. Claude 3 from Anthropic, which is recently adopted by AWS to support all their Alexa conversational use. XAI also came up with a model called Grok. There's a company called Mistral, which is based in France, I believe, and they have done very good job. And their models are really very popular, both open source and closed source. Llama from Meta is an open source initiative, and that is really very useful for organizations who are looking to embrace only open source technologies. And their model, which are from IBM also, with the enterprise grade in terms of data, lineage, governance, and compliance. On the same line, you have small language models. They are nothing but smaller versions of large language models. And they are basically fine-tuned or purposely built for a given task. The key characteristics is essentially they are smaller in terms of memory footprint, both in terms of footprint while it is running, as well as the size of the model in terms of the disk space. They're efficient because they require lesser resources, and normally you would find these SLMs fine-tuned for a given domain so that it can really perform an equally good job like LLM with lesser resources being consumed. They're hardware friendly, and these SLMs can run locally, which takes care of a lot of concern large organizations have where they are not comfortable with hosting models, sharing data either in the form of a context which is provided with the prompt and also the responses. So this is a great opportunity where you can actually use SLMs on localized hardware on your data center and then run these AI workloads without any um, compromise on data security, sovereignty, which is very much uh, desired in large organizations. Some popular small language models are Llama 3. So essentially, you would find most of the models which are available as LLMs with the smaller footprint, and we can put them into the category. We'll see how they can compare with each other. Llama 3, 8 billion is from Meta. Microsoft has 5.3. Google has Gemma or Gemma, whatever way you want to call it. And they are basically in that category of small language models. Now, if we compare SLMs with LLMs, SLMs are basically small in terms of the number of parameters on which they are trained, and they are fit for use on edge devices like mobile or on-premise infrastructure. Since they are small, they are much more optimal in terms of running it on the infrastructure or hardware which is not very powerful. They can be trained quickly. Overall, what I've observed by experimenting personally that SLMs provide you a comparable performance with other benefits like you don't incur the cost, your data doesn't go out, and that really makes them really very promising. In terms of SLM applications, they can be deployed on edge devices like phone and tablets, home appliances, wearables, um, automobiles. Use can be used in education and research and can be embedded for entertainment purpose in game console. So there is a variety of um, use of SLMs across different aspects of deployment. SLMs are gaining momentums purely because of their adaptability and efficiency, essentially allowing you to run it on commodity hardwares like laptops and servers that you probably have already. Allows you to use AI across different use cases, not limited, and basically essentially democratize the use of AI. They can be tailored for a particular domain. They are cost effective. The benefit I see for SLMs essentially, you would have possibly scenarios where applications would be infused with Gen AI capabilities and would be bundled with tailored SLMs as part of the deployment. So because of the smaller footprint, they can be deployed very efficiently and they can run with lesser computing resources to serve business requirements. I've already covered most of it. Low cost in terms of compute. Since they are running locally, provide you better performance and lower latency. You leverage your existing infrastructure and hardware. So from a cost perspective, they are really very cost effective. You can deploy wherever you think and can perform on edge devices, and they can be customized. So before we dive into the demo, Let me just introduce, if you are not already familiar with Hugging Face. Now, Hugging Face is a platform which is similar to GitHub, but this is purely meant for machine learning and AI. You'll probably find a lot of models, data sets, and let me just take you to the site. So if you go to huggingface.co, you would see this page, and you can actually see Hugging Face is a platform that provides open source models. You can see it is providing you a categorized view, audio, natural language processing, vision, multimodal. It also provides you data sets. If you want to build your own model or you want to fine tune a model, then you can make use of these data sets. These are curated uh, data sets that can be used for such purpose. Hugging Face also allows you to test a model. For example, um, I have these models, and this one is the active one, and I can actually test it in a very similar chat GPT like interface, and check how this particular model is useful for a specific uh, use case that I have in my mind. So that's a very good platform for uh, application developers, organizations who are looking to embrace open source model. How things are going to pan out in the future, you probably would have heard Apple introduce Apple Intelligence, which is their AI stack offering Gen AI capabilities. iPhone already have the right chips or GPUs. So if you see here, they already have neural engine and GPUs as part of iPhone hardware. And what they've done, they've actually added the applications, an AI stack where they can actually run a lot of things locally. Currently, it supports language and image analysis, and then it can then be integrated to various apps that are available like Siri or writing tools or image playground. They also host models on Apple Cloud for things which are more complex, and then they basically offload some workload based on what is being requested so that it can serve. And they really have very tight security constructs around everything, and that makes it really very good. The point I'm trying to make here is you would see models running on the edge, and these models are going to be essentially in the SLM category. Similarly, Microsoft has recently introduced Copilot plus PCs. They are nothing but PCs with Copilot, which is their GenAI offering for different functions. And what they have essentially an NPU baked in as part of the hardware, where it can actually perform a lot of AI tasks without involving CPUs and GPUs, so that your experience for the normal operations is not impacted, or you can actually run workloads which involves CPU, GPU, and NPU without compromising the performance. Let's see how we can make use of SLMs locally. So there is a tool called Olama. Basically allows you to run models uh, locally, uh, and you can actually use it to also customize language models. Supports a lot of open source model like Llama 3, Mr. Let me see. So this is the list of the model that Olama supports. And using Olama is very straightforward. Let me give you a demo. So how do you start? You basically go to the site olama.com, I believe. Download this application called so Olama application is available for Mac OS, Linux, Windows. Windows is in the preview, and you download this. It's a normal setup you run if you are using Windows like me, and then once you install this application, you run this command. For example, if I use Olama list, it will show me all the models that have been previously downloaded. And if you run Olama, if you want to run a model, let's say Lava, what it will do, if it is not there already, it will download that model and then run it. So I won't do that, probably to save time. And let's say I want to run Llama 3, which is already downloaded, Llama 3. So what it is doing, it is basically instantiating that model and providing you an interface. It does support an interface which is like this. I say hi, it will respond. Obviously, the performance is not going to be, very fast, considering that I'm using a commodity hardware. It's my laptop. So what is a full form AI? So it's a complete model and language model, and it can really answer um, like ChatGPT. This model is also exposed as an API. So if you are building applications that requires an API call, that can also be made. So you can actually download model like 5.3, which comes in 4 different versions, and you have a mini version which is 3.8 billion parameter. You have a large one which probably would be in the category of LLM. So the difference between SLM and LLM is purely the size, and there is no specific criteria where you can define whether a model is SLM or LLM. The most important thing which is highlighted here for 5.3, and it applies to other, you can actually run these SLMs using different runtimes. So runtimes are the application layer construct that allows you to instantiate a model locally or on a server, and then expose APIs or a chat-like interface for you to really work on. So you have runtime, which is like 1NX, which we'll discuss later in this session. NVIDIA also has a runtime called name. Olama we just saw. I'm going to show LM Studio also, which is a very user-friendly application to run these models locally. And Microsoft has recently released what they call it is a AI toolkit, which also can be used to run models locally and also can fine tune. So let's see what is ONNX. This is basically an AI engine that helps training and inferencing the models. It's like a platform which is available on all popular operating systems like Linux, Windows, Mac, iOS, Android. Supports different languages: Python, C Sharp, Java, JavaScript, C++, and it has been created for an optimized performance and a better memory management so that you can run it locally. And it can actually make use of local GPUs if you have any to perform or offload GenAI workloads to the GPU so that the CPUs can be utilized for other tasks. So let's see, let me just show you how you can make use of ONNX. So I've just written a small application. It's a very simple application. And what I'm doing here, so I'm just using an SDK to run this model locally called ONNX runtime. That's what we have discussed. I have downloaded this model locally. So this is the model that this application is using, and it has different versions for CPU. CUDA is basically NVIDIA GPUs and DirectML. So essentially, it's just few line of code. You have basically the path for the model, and you are instantiating the model, creating an instance of the model and a tokenizer, and that's it. So if you run this application, what you will see, something that is basically used by C# application, which is here. You can actually do anything. You can embed it in a web application or build an API on the top of it and expose it for the consumer. So let's ask, what is the full form? I'm purposely asking a smaller question just to save time. I'm just trying to prove a point that these models can run locally. So it gives you the response like any other interface that you have for hosted models on Google or Azure. So that's about ONNX. Let's go back to the presentation. So now these models are basically quantized. They are basically optimized in terms of the size and the memory footprint. And this process is called quantization. So what you do in quantization, you basically convert the model parameters, which are weights and biases, from a high precision value like a floating point number to a low precision value like an integer, which requires smaller bits without compromising a lot in terms of accuracy and other parameters related to the model performance. And the purpose of quantization is essentially to reduce the storage requirement. So if you see a 70 billion model would probably will be around 1.4 gigabyte, where each parameter consuming 2 bytes. If you quantize it, you can actually reduce the size by compromising the accuracy and performance parameters in a minimal way. Because of the size, you can actually run it locally. Um, and these models reduce the power consumption. However, there is a compromise in terms of model accuracy. So it comes with the cost. But in most of the cases, the performance is good enough for a given use case. And these quantized models basically are stored in a GGO format, which is a binary format for models on your operating system storage. LM Studio. Now, this is an interesting application, very user friendly. It is available for Mac, Linux, as well as Windows, and it's a good start for anybody who wants to start playing around with SLM, start using these models locally to build application on the top of it. It really allows you to work purely on your localized hardware in an offline mode and run it privately. That means whatever you do, that stays within your laptop or device. It supports a lot of open source model, and if you have high security and data privacy requirement, this is a really very good application to work with. Let's see. Like I said, it is available for Apple Silica M1, M2, M3 series, available for Windows and Linux. It allows you to run models locally. You are provided with a chat interface as well as an API server that you can expose to consume this API in a RESTful manner using OpenAI API standards, and also allows you to overall management. So let's see in the demo. So let me launch LM Studio and show you how it works. Let me close this. So when you launch LM Studio, you'll get this interface. It gives you some sort of a dashboard where you can actually search Hugging Face for different models. And let's say if you're looking for a particular model, you select and you can download it. So I can show you, I've downloaded these two models, Phi 3 and Llama 3, and also an embedding model called Nomic. You can manage, delete if you do not want to continue with that model down more. So how do I use these downloaded models? So these downloaded models will appear here. So let's say I want to use Mistral 7B. I have option to configure it before instantiating it. For example, you want to offload some of the workload to the GPU, you can configure. There are other parameters that you can set. Now, once this model is loaded, you get a chat-like interface, and let's ask the same question and see how it performs. Obviously, this is running locally on a commodity hardware. The answer remains the same. I am maybe I've asked it previously also, and you get a response like this. If you after experimenting, and if you want to use this model through an API, so you can actually instantiate a server. What it does basically, so you have this model ready, you can just start a server, and in fact the latest version of LM Studio allows you to launch multiple models. So once this server is started, the same model is exposed on port 1234. Let me just fire Postman so that I can show you. And you can actually make an API call. You can also expose this server locally. That means on your LAN, all other computers can have access. This model's sort of a, a local hosting of model. And you basically can use an API which is hosted on localhost port 1234 on this endpoint. For example, I'm asking what is 5 plus 7. Now this is how you call an API. So you have to have a post operation for this URI, and you would have a request body with our parameters like temperature, maximum token, and the question in the content. So let's fire this and see what we get. Now this is basically similar to what we were doing here, but this interaction is over API. So if you see, it wasn't really very fast, but good enough. So you see the response you get is 5 plus 7 is equal to 12, and all other details. Also provides you information how many tokens were consumed, both in terms of prompt and completion token, and other information. Now, why this is important? So if you are building a Gen AI app and you are looking to host it locally, you would probably either use an SDK that I've shown you for ONNX, or you would use a standardized REST-based interface to call this model for inferencing. So that's pretty much I have for today's session. And let me go back. Yep. Now, if I summarize what we have covered today, we have understood language models, both LLMs and SLMs. We also saw the application of the small language models. Essentially, these models provide you the ability to run Gen AI locally in a secure, private, in a cost-effective manner. And I also provided you different applications that can allow you to run. For example, we have discussed Ulama, we have discussed ONNX, LM Studio. For anybody who's starting new, LM Studio is a very simple option to start with, and then gradually take that to the next level. That's all for today's session.